Hey guys, today we are going to be using inverse properties to simplify logarithmic expressions. So here I have log base 3 of 3 to the x power, and I want to know how I can simplify this. Well, because of what we know about inverses, I'll tell you that g of x is equal to log base b of x is the inverse of f of x is equal to b to the x power. Now, because of what we know about inverses, we know that g of f of x is equal to the log base b of b to the x power is equal to x. And f of g of x is equal to b raised to the log base b of x is equal to x. Now, this might seem confusing, but what I'm going to do is I'm going to leave these as a model for simplifying these logarithmic functions, okay? So I have two examples as models. I have log base b of b to the x power is equal to x, and I have b raised to the log base b of x is equal to x. All right, so my first problem here is log base 3 of 3 to the x power. Now, which one looks more like this example? Well, it would be this one here, right? So if I write underneath that log base b, b to the x power, log base b, b to the x power equals x. Well, if b is 3, then I know that my answer here is simply x. Whatever number you plug in for b here, if this is an x, then the answer is going to be x. So our answer is x. So here I have 5 raised to the log base 5 of x power. Which one does this look more like? I'd have to say that it looks more like this one. So if I write underneath it, b log base b of x equals x, you'll notice that b is 5 in this one. So because of that, I know that my answer for this one is x. So here I have 7 raised to the log base 7 of 3x power. All right, this one looks like it has the log and the exponent. So underneath, I will write b to the log of b of x power equals x here. Well, notice that this part here and this part here match up where b is 7. Now, in the place of x, I would write 3x because that's what's left. If you notice, this part kind of cancels out, okay? If we look at it like that part cancels out, what's left after we cancel that part out? Well, on this one, it's x. So on this one, it would be 3x. So our answer to this one is 3x. Here I have log base 4 of 16 raised to the x power. All right, and I need to find out what does this equal if I simplify it. Well, of our models, which one does this most look like? It looks like this one. So underneath, I will write log base b of b raised to the x equals x. Well, you'll notice that here I have a b and a b, which need to be the same thing, right? Well, these are not the same thing. I have a 4 and a 16, but what I can do is make this log base 4 squared to the x power. And what we know about exponents is I would just multiply my 2 and x to get 2x. So, similar to the last problem, this now looks like this. And remember, this kind of cancels, right? So we're going to cancel that. And notice that whatever that exponent is going to be the answer. So what's our exponent here? I'd say it's 2x. So our answer is 2x. So here I have log base 3 of 27 to the x power. Now, which model does this look like? Looks like the first one here starts off with a log. So I have log base b of b to the x power equals x. All right, so remember, we got to get this looking like this, where b and b are the same. Well, this one, they are not the same. But I do know that 3 to the third power is 27. So I will rewrite this as log base 3 of 3 to the third power raised to the x. And I know that I can rewrite this as log base 3 of 3 raised to the 3x. Well, now we could just take this part here, cancel, this part here, and cancel. And our answer for this one is 3x. All right, so here we have 10 raised to the log of 5x. Well, what type is this? Well, this looks like we have the log as the exponent, so it'll be the second type. All right, so underneath, I will write b log base b of x is equal to x. Well, you may notice that there is not a base here. At least there's not one visible. Remember that if there is not a visible base on a logarithm, that it's 10. Now, this part of the expression looks like this part of the expression. And we know that we can just cancel that, so that means we can cancel this. And since the answer to this one is whatever the exponent is, that means the answer to this one is whatever the exponent is. So it'll be 5x. So our answer to this is 5x. And that's how you use inverse properties to simplify logarithmic expressions.